What's up, team? This is Ro, your best friend at JMSB. So here I was asked a question for COMM 308, Introduction to Corporate Finance. Let's have a look. You're going to pay $800 into an account at the beginning of each of 20 years with the first payment today at t equals 0. The account will then be left to compound for an additional 20 years. At the end of the 41st year, you'll begin receiving a perpetuity from the account. If the account pays 14%, how much each year would you receive from the perpetuity? Round to the nearest thousandth. So the truth is, I really like this question. There's a lot going on here, and it really tests your ability on having a good foundation with time value of money. In this question, we have a $800 annuity. It then turns into a single cash flow for 20 years, and then it's followed by a perpetuity. So you really have to know all the different types of cash flow streams and how to value them and move them along a timeline to be able to tackle a question like this. But once you get good at it, it's really quite straightforward with the help of your financial calculator, at least for the most part, except once we start dealing with the perpetuity. So if we have a look at our financial calculators, the very first step is to value the annuity due at time 20. So on your finance calculator, you're simply going to press 800 followed by payment. We're going to press 20 followed by N. We're going to replace IY with 14, and we want to press second followed by payment and then second enter to set the annuity to begin. And that's simply because it's an annuity due, as we can tell the payments are happening at the beginning of each time period. We can press second followed by IY to ensure that PY is set to 1 and that CY is set to 1. This ensures that the compounds per year and the payments per year are both set to 1. I can press second followed by compute to exit that worksheet, and now I can simply press compute followed by future value. So I get an answer of 83,000 and some change. And now what I want to do is I want to grow this amount for another 20 years. So I'm simply going to press present value. I'm going to replace 0 for payment. It doesn't matter if I keep the payment at beginning or end, simply because I put 0 for payment. I can press 20 for N and compute the future value. So this is the value at time 40. And now in order to find the value of the perpetuity payment, you simply need to multiply this by the discount rate, which is 0.14. And that should get you the answer, 159,727. So rounded to the closest thousand, that would be 160,000. So I hope this helps, and if it does, make sure you tag your friends that are taking the course. In the meantime, I hope you guys keep well, you study well, Row out.